And we said that if you have log of A times B, that's equal to log of A plus B, okay? And that's equivalent to, let me pull out my own notes here. Okay, that's equivalent to, and really it could be any number, but it could be like if you have the log of 3x squared, okay, that's equal to the log of 3 plus the log of x squared, okay? And that's just a log property. You can, if it helps you, you can divide it like this. If it doesn't help you, then you don't divide it like this, okay? So same thing on your notes. You have log A over B, and this says log, but the logs could be log. Okay, actually, one thing you need to know for the test, and you have it on your review too, is that if this is log and it doesn't have any number, it actually is log 10, log base 10. Okay, we don't have to write it every time it's log base 10, but just FYI, it is log base 10 if you don't have it written. But this rule doesn't just apply to log base 10. It applies to any log as long as it's the same all the way through. So if I called this log base E, okay, and this was 3 over x squared, this would be equal to log base E 3 minus log base E x squared. Okay, do you guys see how I'm breaking up? These are just log properties, okay? If there are two things that are being divided here, then this is equal to log of the top minus log of the bottom, okay? And the way I remember this is 1 log multiplication equals 2 log summation. And over here, this is 1 log fraction equals 2 log subtraction, okay? And so in your notes, you have these things that look like, they look like dividing lines, but I wanted you to actually write in the blanks. They're actually blanks, even though it looks like a line to divide your paper in your notes. Okay, I think I switched them, so I apologize for that. But the top one, I think, is 1 log multiplication. Okay, 1 log multiplication equals 2 log summation. Okay, and the bottom one is 1 log fraction equals 2 log subtraction. So I kind of switched, it's switched top and bottom from what I have here, okay? And I want to encourage you guys to memorize this, this rhyme. But I also want to tell you that when you make up a rhyme, just because it rhymes doesn't mean it's true, okay? So this is 1 log multiplication equals 2 log summation. But if you say 2 log multiplication equals 1 log summation, that would still rhyme, but not be correct. Does that make sense? So we need to remember it the correct way. So I'm going to kind of give you a visual picture up here, okay? The problem is after you see this, you can't unsee it. But 1 log multiplication equals 2 log summation. I think of it like this. Like if I stand in front of you and I have 1 log, 1 leg, 1 log. I put my legs together. That's 1 log, okay? So 1 log multiplication equals 2 log summation. Check that out, okay? So the way you memorize this is you start with 1 log, okay? So 1 log multiplication equals 2 log, you see 2 legs, summation. Guys, I can only see your eyes and no one's really smiling, but that's okay. All right, and then you have 1 log fraction equals 2 log subtraction. The way I remember that is it always starts with 1 log, leg, okay? I don't think online they can see me at all. Okay, so y'all gotta see this. Okay, so 1 log fraction equals 2 log subtraction. So I think about it as this is 1 leg fraction, okay? So 1 leg fraction bar, okay, equals 2 log subtraction. I should jump, okay, to finish that off. But I want you guys to memorize that. That'll help you. But you also have to understand really what it's saying, okay? So what is 1 log fraction? Guys, this is 1 log fraction. This is ln, and it's a fraction. But this actually isn't 1 log fraction equals 2 log subtraction. Because 1 log fraction equals 2 log subtraction is when the ln actually applies to the whole fraction, okay, not just the top, okay? So this is 1 log fraction equals 2 log subtraction. Over here, this is 2 log fraction. Do you see that? And that's not the rhyme. The rhyme is 1 log fraction, okay? And so just because 2 log fraction still rhymes doesn't mean it's right, okay? So make sure you don't start out with 2 logs fraction, okay? It's 1 log fraction. This one is 1 log subtraction. Well, that's not right at all. Everybody good with that? Because when you saw me up here, it wasn't 1 log subtraction. It was 1 log fraction, division. How about that? Fraction, okay? So that's not right either. And the final one over here is the correct one, 1 log fraction. So 1 log fraction equals 2 log subtraction. On your exam, you'll see a problem like this, ln of x minus 1 over x plus 2, something like this, not exactly. But if you see this, this is 1 log fraction. Does that make sense? Okay. Then you also have 1 log multiplication equals 2 log summation. Okay, and then the same rules for this, okay? 1 log multiplication, you start out with 1 log. So if it's 2 log multiplication, that's not this problem. That's not this property. It's got to start out with 1 log multiplication. Now, this one looks like 1 log multiplication, but the log needs to apply to these two things. These two things need to be multiplied, not a log with something else, okay? So this one actually is not 1 log multiplication either. Even though it is 1 log and there's a multiplication, you got to have the parentheses here. Like this has to be a times b, not ln of a, okay? Not the log applying to just the top part, okay? So this one's not 1 log multiplication either. Well, it is if I put the parentheses in, but it's not the way it is now. This is 1 log summation. Guys, the rhyme is not 1 log summation. Even though it rhymes, it doesn't mean it's true, okay? So it's 1 log multiplication, and so this is not right. So guys, this is what 1 log multiplication looks like. ln, and I have ln, but of course it could be log, right? Log 10, log e, log whatever, and then 2 things multiplied by each other, and that's when you can separate it with 2 log summation. Okay, so why is this useful? Well, we talked about yesterday and how to take derivatives, right? Okay, let me just, wait, I think I thought I put the slides in here, but maybe I didn't. The slides that kind of look like yours. Actually, I didn't put it in here. So go look at your notes. And can you guys pick A, B, C, or D? Which one is correct? So it's not, I'm sorry, it's not in my slides, but you guys have your notes, okay? In the middle of your paper, it says, which is true? Do you see that? Okay, so which one is true? A, B, C, or D? When I say 1 log multiplication equals 2 log summation, which one is it? It's D. So that should be D as in dog. Look at the next one underneath that. Okay, we're saying 1 log fraction equals 2 log subtraction. Which one's correct? A, B, C, or D? And we're looking at your notes. D. Okay, is everybody good with that? So make sure you recognize that. And why is this useful? Because let's go ahead and do this problem right here. This is where it's useful. Okay, what you want to do is take the derivative of a log. Okay, so here we are. I'm going to take a derivative of a log problem. Okay, and remember how to take a derivative of a log problem. The answer to y prime is equal to u prime over u. Now, y prime is only equal to u prime over u if there's a log here. Is everybody good with that? And there is a log, okay? So it's equal to u prime over u. All right, well, what is u prime? Okay, u prime is the derivative of u. So you guys good? This is my u, okay? So it's the derivative of this divided by this. Do you see what a huge problem that is? Okay, like you have to take the derivative of this. Do you see, if you take the derivative of this is quotient rule, product rule, and a stomach ache all rolled in one. Do you guys see that? Okay, so when you do that, you're like, dude, I don't want to do that, okay? And so, well, actually, you can't measure your I don't want to do that by if you should do it or not, because in calculus, you may not want to do a lot of stuff. But you can see that's going to be really hard. So let's use log properties. And you can only use log properties if you have a log, okay? So what does log properties say? It says, guys, look, do you see that this is 1 log fraction? What is 1 log fraction? Isn't 1 log fraction equal to what? 2 log. So there's my top log, okay? This is my A on the top. 2 log subtraction, right? 1 log fraction equals 2 log subtraction, okay? So it was really hard to get u prime over u of this. But guys, could you get well, let's look at this one. Could you get u prime of u over this one? This one's not too bad, right? If this was your u, okay, could you take the derivative of this, u prime over u, okay? But you can make this even easier. This one, do you see, I still have to do product rule, right? How could I avoid product rule on this using log properties? Because you guys know 1 log multiplication equals what? 2 log summation, okay? So I can divide this even more, okay? ln of x squared, this is like your a, right? This is like your b. So 1 log multiplication equals 2 log summation. Okay, and I'm just going to copy this right side. Okay, is everybody with me so far? Make sure you understand, I haven't actually done any calculus, okay? All I've done is just do log properties. It's basically algebra 2, okay? But this makes my calculus easier because look, I thought I had to do 1 problem, okay? But look, oh boy, I get to do 3. Do you see that? Oh boy, oh boy, oh boy. Do you see that? Okay, now these 3 problems are going to be easier than this 1 problem. Do you guys see that? Like, how do you take the, I don't know if you guys see it. Do you see it's 3 different problems here? Okay, if I take the derivative, I can even make this easier, a little bit easier using log properties. There's another property, okay, and that's on the top of your paper. There's another property that says the log of AB, so if I have the log of x squared, that's actually equal to, as long as it's a log, you can move the exponent to the front. So this is actually equal to, let me just write it, the log of x squared is actually equal to 2 log x, which is a weird, funky thing that you can actually just take the exponent and pull it in front of the log. That's how log properties work, okay? And so if that's true, do you see an exponent on this? 2, right? So this is actually 2 ln of x, okay? Now this is a little bit tricky, but do you see an exponent on this? 1/2, right? So this is actually 1/2 log of x cubed minus 5x plus 7. And then finally, do you guys see an exponent on this? The 4, right? And the exponent has to be on the whole thing, okay? The whole u, and it is, okay? So this would be minus 4 log x squared plus 3x. Okay, this is your y. I still haven't taken the derivative, okay? But the cool thing is this. I've moved it to a place where taking the derivative is a lot easier. I thought I got to do 1 problem, but oh boy, oh boy, oh boy, I get to do 3. And there are 3 actually fairly simple problems. Look at this. 2 times ln of x. Isn't the 2 just a scalar, right? So, and when you're taking the derivative, so let me go ahead and do it now. I'm going to take the derivative. Can't you just pull down the 2, right? So 2 times, what's the derivative of ln of x? Do you guys know? It's u prime over u. This is your u. What's the derivative of x? 1. What's your u? X. So this is just 2 times 1 over x. Okay? Plus what? This 1/2. Okay? This 1/2 is just a scalar. You just pull it down. Okay? Now, if it were 1/2 x, that would be different, right? Because 1/2 x would make this a product rule. Okay? But it's just 1/2 times something. It's just a coefficient. Okay? 1/2 ln of this. Well, what's the derivative of ln of x cubed minus 5x? It's u prime over u, right? This is your u. Your u is whatever the argument is with ln. So what's the derivative of this? 3x squared minus 5 divided by your u, which is, you just copy it. You guys getting the hang of it? Okay, you guys do the last term. Did you get the same thing? Okay, now I would be happy if you just left your answer like this. You do need to understand though, your test is multiple choice. And while that makes some of you guys happy, you have to realize multiple choice isn't all it's cut out to be, because you have to make your answer match the multiple choice, okay? And so make sure you understand there are actually parentheses here. There are actually parentheses here. I mean, there are actually parentheses on top and bottom, okay? This is really 4 over 1. So if you multiplied, you'd have to distribute the 4. Okay, this is really 2 over 1. Okay, so if I reduce this, this would be 2 over x. I'm actually not going to reduce this. I don't think there's a lot of good in reducing it, but just FYI, this would be 2 times the whole bottom here. And then minus 4, you'd have to distribute the negative 4 here, okay? You don't have to do that, but I'm going to go ahead and do it because on your test, there are some problems where you have to distribute like this. So negative 4, so let me just put a plus sign. This is really plus minus, right? Plus minus, negative is really plus minus. So it's plus negative 4 times 2x, which is negative 8x, plus negative 4 times 3, which is negative 12 over x squared plus 3x. Okay, and that was just something simple to remind you guys how to distribute negatives. Okay, and that is my final answer. Okay, the next problem on the back page, I'd like you to do that. Okay, so what I want you to do is take the derivative of this ln problem. Now you can avoid product rule, okay, u prime over u, if you remember your log properties. Luke, can I see your video, please? Yeah. It's on Tuesday. You're going to get a review on Friday. You'll start your review for your test. You'll work that on your own. And you have Monday, ask questions, and then Tuesday's your test. Thank you, Luke. So guys, someone asked, when is our test in here? It's on Tuesday. Your review, it's pretty much already done. I don't know if I put it up or not yet, but it's pretty much already done. And I think I did put it up, so you can look at it, although I don't think you can access it in my math lab quite yet. And your test will be on Tuesday, okay? You really want to work on your review this Friday and the weekend so that you can ask questions on Monday. Otherwise, you won't have any time to ask questions. You'll just show up to the test on Tuesday. Okay, this is u prime over u. You agree with that? Okay, so let me just show you the long way to do it, okay? The long way would be you take the derivative of u. But do you see that that is a product rule? Okay, so you would do, and I don't know if I'll finish this, but it'll be the derivative of the first times the second plus the derivative of the second. But this second is really 3x minus 1 raised to the 1/2. So it's chain rule. So the derivative of the second, take the power down by 1, leave the inside alone. Okay, what does it mean to leave the inside alone? It means leave the inside alone. Okay, then multiply by the derivative of the inside over, okay, and then you copy your u, x square root of 3x minus 1. That is the answer to this u prime over u, okay? And if I simplify things, I don't know how much I want to simplify it, but I guess I'll keep going. I've got 3/2, okay? This is 3x minus to the 1/2, so I'm going to move it to the bottom, so it's positive to the 1/2 over x square root of 3x minus 1. And there are other ways I can simplify too. This is really a square root here, okay? It's a little bit messy, okay? What I want to show you is you can use log properties, okay? So I'm going to leave my work there, and I'm going to come down here and use log properties. Actually, I can't leave my, I got to copy this because I can't memorize it. So let's just go ahead and copy this, and I'm going to put it down here. Okay, so I'm going to do this using log properties. I want to show you how much easier it is, but you have to recognize log properties. You have to recognize that 1 log multiplication equals what, guys? 1 log multiplication equals 2 log, and you just rotate it, right? 2 log summation. So what this is y is equal to log x plus log of square root of 3x minus 1. 1 log multiplication equals 2 log summation, okay? And then what you have here is you thought you just got to do one problem, but oh boy, you get to do two. And this one's not hard to do. You could change the square root if you want to. Okay, this is really ln of 3x minus 1 raised to the what power, guys, of the square root? 1/2. Okay, I'm going to take the derivative of this. Now it's totally up to you, and we can vote on this. Do you want to move the 1/2 to the front or not? Because it'll work both ways. Do you want to? Okay, so if you want to, just make sure you know you do it on your test too. Now, when you move that 1/2 to the front, it doesn't mean move it to the very front. Okay, that's not how log properties works. It just means for that expression where you had a log, you move it to the front of that log. Okay, then what you do is you say the derivative of ln of x. Guess what? That's not very hard. This is your u. So it's the derivative of x over x plus, okay, this 1/2, guys, is just going to be carried because it's a scalar, it's a coefficient, because you're just going to keep it there. Then you take the derivative. I've already eliminated this 1/2, so I'm going to scribble it out. Then you're going to take the derivative of 3x minus 1. What's the derivative of 3x minus 1? 3 over what? You see how easy that is, okay? And this actually is the same answer as this up here, okay, but without the stomachache. Is everybody good with that? And you guys would have to, I'd have to do a little bit of manipulation up here to see that it's the same answer, but I can actually kind of see it. It is actually the same answer if you simplify this up here, okay? All right, so that's using log properties. I want to go ahead and do log A with you guys. Log A, I think, is kind of hard. It's really not because it's hard, but what it is it's hard to remember, okay? When you're in Algebra 2, you remember, you learned this thing called change of base formula, okay? And what it was is you have log 2, 3, okay? That's actually equal to log 3 over, oh, sorry, not log 3, ln of 3 over ln of 2, okay? And I think I have a space for that for you right there in the first example, okay? That's what the change of base formula is, okay? And so we've already learned well, let's do this. This is what I'm trying to do, the derivative of log AU. We've already learned that the derivative of log EU, okay? Remember, log E is really ln. Log E is so popular. It's used in finance. It's used in a lot of other things. It's so popular that it turns to ln. It's used in economics, okay? So this is the derivative of ln of U, okay? And we've learned that that's U prime over U. Do you remember that? Okay, but we haven't done a log A. And A meaning it could be any number, maybe not just E, okay? And it turns out that this is really the derivative. Okay, if this change of base formula is true, then this is the derivative of log U over log A, right? All I'm doing is saying log 2, 3 is log 3 over 2. So that means log AU is log U over A. Does that make sense? Okay, I'm just using this thing called the change of base formula. Now, you may or may not understand this, but this A, all of our A, B's, and C's in calculus are constants. They don't look like constants, but they are. They're 3 or 5 or 7 or 10, okay? And if it's a constant, you can actually pull it out, okay? So this is actually 1 log A times the derivative of log U, okay? I know that looked like a magic trick, but log A really is a constant, okay? You can pull it out because A is some number, okay? It represents some number. But the derivative of log U is something I already know, right? What did I say the derivative of log U is? That's just U prime over U. So all suffice to say, this is where this formula comes from. So I'm going to write the formula for log A. And you guys have it on your paper, I think, right? In the middle, do you guys have it? I don't know if you guys wrote it or not. But the derivative of log AU turns out to be 1 over ln of A times, and the derivative of ln of U, isn't that U prime over U, right? So U prime over U times 1 over ln of A. Another way to write it is U prime over U ln of A, which is probably how I do it more often, exact same thing, okay? And just like your other formula, this can be written as, this is really du dx, right? And remember, numerators can bounce out. So this is actually the same as 1 over u ln of a times du dx, okay? So you're going to see this most often, just FYI, you'll see it most often, oops, in this format here or in this format here, okay? So go ahead and fill out your box there in the middle if you haven't already. This is what the derivative of log AU is. It's these two things, either or. Sometimes one is easier than the other. Okay, we're looking at page, I guess it's page 4 in your notes. Okay, fill in that box. So let's say, let's talk about how to do this problem. What if you have log 7, do I erase this? No. Log 7, 2x minus 3, I want to take the derivative of that. Okay, guys, it's just like what you did before. It's u prime over u, okay? So here's my u. Okay, u prime, which is 2, u is 2x minus 3. You guys see how easy that is? But all you have to do is add in this ln of a. And this is where students have trouble, but it's not actually very hard. Okay, now I'm going to put this in parentheses, okay, because it actually has to be this whole thing multiplied by ln of 7. You see where I got the 7? It's just whatever this base is, and this is a 7. Okay, everybody ready to do these problems? Again, they're not very hard. It's just, it's hard to remember the formulas, okay? So here's another one you have to do. Okay, this is the derivative of log u. Same thing. Here's my u, okay? U prime over u. Let's do it. U prime, okay, over u. You got it? U prime over u, okay? But this is a log what? 6. So don't forget ln of 6. You guys see how easy that is? Is everybody with me? Let's do this one, log 10x. Go for it. U prime over u first. So here's your u. 1 over x, right? Don't forget log 10. You guys got the drift of this? Okay, do the next one. Do you guys have this on your paper? Yes. U prime over u. Log 7. Did you guys get it? Okay. Let's do another one. This one has a sign, I think. Oh, maybe not. Okay, this one. Okay, do this one, guys. It's not hard. Don't let the sign throw you off. You know what the derivative of sign is. Okay. So u prime over u. There's your u. We're going to take the derivative of this. So f prime of t. Okay. The derivative of sine t is cosine t times the derivative of t, which is 1. Okay, you have to do the d dt, divided by sine t, right? But don't forget, because this is not an e, it's a 3, so don't forget ln of 3. You guys feel good about this? It's not super hard. Again, it's just a formula thing, and it's really hard to remember the formula, okay? Now, you can also use log properties on this, okay? So let's say I have this problem here, okay? So I have log 3 x squared over x minus 2. Now, I could do u prime over u. So once again, this is my u. Do you agree with that? So I'll just do u prime over u. And I'm going to do it the long way first, just to make sure you understand. The long way is, okay, the derivative is equal to the derivative of this. But do you see its quotient rule? I'm starting to get a stomach ache already, okay? But you do the quotient rule. So you're like, okay, the derivative of the first times the second minus the derivative of the second times the first all over the bottom squared. That's u prime, but I also need to divide by u, okay? This is actually the derivative. There's nothing wrong with this, except it's ugly and it's not simplified, okay? But there's an easier way to do it. Do you see I have 1 log what here? 1 log fraction, do you see it? Because 1 log fraction equals 2 log, what guys? Subtraction. One day we'll do like a pep rally. We'll do all our cheers at one time, okay? We'll get all of our calculus cheerleaders to help us, okay? It'll be so fun. There won't be food though because of COVID. All right, so 1 log fraction equals 2 log subtraction. So let's do it. 1 log fraction, and the log here is just log 3. Okay, so f of x equals 1 log fraction equals 2 log, and you just copy the log, subtraction. Is that the bell? Okay, good. 1 log fraction equals 2 log subtraction. Okay, and then I can do this manually. Okay, so I could move the 2 to the front, but let's not. You don't actually have to. U prime over U, guys. You ready? We're going to take the derivative. I thought I got to do 1 problem, but oh boy, I get to do 2. This is going to be U prime over U. Do you see that? What students do wrong for some reason, I don't know why, is they carry down the log here. Okay, well, remember the formula for log U, the derivative, is U prime over U. It's not log U prime over U. Does that make sense? So it's just U prime over U, but don't forget, what am I forgetting? Log 3. Okay, is everybody seeing how this works? Okay, a lot of little details you need to remember. That's not hard to do. Okay, what's U prime over U here? 1 over x minus 2. Okay, but don't forget. Okay, if this were just ln, that's all you'd have to do. But since it's log 3, you also need an ln of what? 3. Okay, and that is your answer. And if you wanted to compare this answer with what I got before, it's the same answer, I think. Wink, wink. I don't know. I actually erased it, so I don't know. Okay, hopefully it is the same answer. Actually, it is. I just didn't really check. Okay, you also need to be able to do tangent lines with this, so let's go ahead and do a tangent line. Okay, guys, when they ask you for an equation of a tangent line, you need 2 things. What are the 2 things you need? A point and a slope. Okay, look at your problem. Do I have a point anywhere? Okay, 2, 0. Look at the problem. How do I get a slope of a tangent line? The slope of a tangent line. When I say derivative, you say slope of a tangent line. So guys, what am I getting over here? The derivative. Okay, so what I need to do is get the derivative of this right here. Okay, I'm going to rewrite this. This is really log 4 x squared minus 3 raised to the 1/2. Okay, this is f of x. So take the derivative of this. How do you take the derivative of a log? Isn't it u prime over u? Right? Okay, now you guys tell me, do you want to move the 1/2 to the front or not? You do. Okay, so let's move the 1/2 to the front. Now, if you don't, just make sure you understand. I mean, I'd just do chain rule here. It'd be fine. Okay, but this would be 1/2 times. Now I'm going to take the derivative of this. Okay, what's u prime over u? Go for it. U prime over u. Okay, but I'm forgetting something. What am I forgetting? ln of 4. Do you see how easy that is? Okay, the nice thing is something cancels out too. Do you guys see what cancels out? The 2s are going to cancel out because it's being multiplied. Okay, as long as they're being multiplied, they can cancel out. Okay, so right now I have f prime of x is equal to x over x squared minus 3 quantity. Make sure you understand that this is your u, so it has to be together, okay, times ln of 4. All right, the problem is, guys, I need a number for the slope. A lot of students will leave it like this, but you can't leave it like this. You need a number. You need a number for the point, you need a number for the slope, okay? How can I change this into a number? The x's are really 2's. The x's are really 2's. So all you do is you come through, okay, you change all the x's to 2's. That's going to be 4 minus 3, right? ln of 4. ln of 4, guys, even though it looks terrible, it's a number. Is everybody good with that? You can go in your calculator, punch in ln of 4, and you can figure out what number it is. But it's not really important. It's kind of like pi. You can just leave it in your answer, okay? So is everybody good? That's my answer, 2 over ln of 4. All right, let's go for it. Write the equation of the tangent line. We already know how to do this. Go ahead and do it. Y minus y is equal to the slope times x minus x. Y minus y is equal to the slope. I know the slope is ugly, but that's the slope times x minus x. And that is your answer. It's unsimplified. Your test is, multiple choice. So, your test wouldn't have this minus 0. You might have to distribute this, okay? And it's not such a big deal. If you had to distribute it, you would just multiply, this times both of those things. All right, and that is your final answer. I would actually stop here and check my work. But if that isn't in the multiple choice, I would distribute it, okay? How are you guys feeling? Okay, let's go ahead and pull out your homework and let's just talk about problems that you guys are having in your homework. There are some problems that are harder than others. I don't know if I have a copy of your homework here. I don't. Okay, did you guys start your homework? This is going to be due tonight. Hopefully you did some problems so it's not overwhelming. If you did start your homework, what questions do you guys have that I can help you with? Oh, here's a homework. And tonight you should be able to finish all of it. Yeah, Paige. Okay, guys, let's look at number 16. Oh, yeah, number 16 is a definition of a derivative. Okay, see if you can see this. Number 16 on your homework, okay, it's your homework due tonight, is the limit as x goes to e to the negative 2, ln of x plus 2 over x minus e to the negative 2. You may or may not see this, but if you have your formula sheet, okay, pull it out. If you have your formula sheet, okay, you should have something on the front of your paper. And we filled this out, I think. Yeah, I'm actually sure we did. That looks like this. The definition of a derivative, the alternate definition of a derivative, is a limit as x goes to c of f of x minus f of c over x minus c. And if you know this formula, when you look at this, it'll look a little bit more familiar because you'll be like, oh, look, this is a C and this is a C. Oh, look, these are both the same, right? Oh, this is f of x. And this would be if you plugged in C into f of x. Well, let's think about this. If this were f of x and I plugged in C into f of x, that would be the ln, because this is f of x, the ln of e to the negative 2. And we did this yesterday, guys. What happens when you log a tree? The cat falls down, okay? So what is this equal to? Negative 2. That's actually not right. Oh, no, it is right, because it's minus negative 2, right? And that's where this plus 2 comes from. So this is the definition of a derivative. What does that mean, that's the definition of a derivative? That means this is equal to f prime over x, f prime of x. Actually, f prime of c, to be specific, okay? And we've done this before. Do you remember how to do this? First, you get the f of x, right? Then you take the derivative of that. Then you plug in whatever your c is. And my c here is e negative 2. Do you remember doing this? We've tested on it, but it's been a long time. Okay, so guys, look at this. What's the f of x? Here's my f of x formula. So where's the f of x? ln of x. So f of x equals ln of x. What's the derivative of ln of x? 1 over x, right? Okay, now everywhere there's an x, what am I going to plug in? I'm going to plug in a c, because the answer is the definition of a derivative. The answer is a derivative. So the answer is 1 over x, but it's got to be a number, okay? And so what is the c that they plugged in? What's the x they plugged in? E to the negative 2, right? But another way to write this is what? If you have a negative exponent, how do you change it to a positive exponent? You move it to the top. And I should pray, because is this a multiple choice? Oh, no, it's not. So I don't know if I got it right or wrong. Is that right? Okay, good. All right, what other questions do you guys have? Yeah, Paige, you have another one or you're good?
I did have one more. I had 17.
Okay, 17. 17 is find the relative min or relative max, okay? Increasing, decreasing, relative min, relative max. Which test is that, guys? First derivative. If the first derivative is test, let's take the first derivative. Y prime, we're looking at 17, equals 2 times 1. Leave the inside alone, take the power down by 1, and don't forget to multiply by the derivative of the inside. You guys good with that? Chain rule, right? Okay, when I take the first derivative, so that's really 2 ln of x over x, I set it equal to what? Do you guys remember? 0 or what? D and E, okay? And those numbers I'm going to put into the f prime number line. This is y prime, same thing, okay? When I set this equal to 0, this is really 0 over 1, okay? If I cross multiply, do you see I get 2 ln of x is equal to 0, okay? That means ln of x is equal to 0, okay? Guys, I need to solve for x though. I don't want to solve for ln of x. I want to solve for x. How do you solve for x? How do you pull an x out of an ln? How do you pull an x out of an ln? What's the inverse property of ln? E, right? You e it, okay? So what you're going to do is you're going to e both sides. So what you get is e ln of x is equal to e0. Is everybody good with that, right? If you log a tree, the cat falls out. It turns out if you tree a log, the cat falls out too. So when I tree this log, what comes out on the left side? X. What's e to the 0? 1. Okay, so that's one of my critical points, 1. Okay, let's go over here and find another critical point. Where is this going to explode? What's going to cause this expression to be d and e? If my x is equal to what? 0, right? So there's my other point here. Another way you can do is just set this equal to 1 over 0. Okay, and when you solve this, you'll get x is equal to 0 when you cross multiply. Okay, so I've got my critical points here, 0 and 1. And another critical point would be, you know, your x's can never be negative, x can never be less than or equal to 0. But I'm going to actually just cross that out because my x can never be less than or equal to 0. And we've done a problem kind of similar to this. So I'm just going to test points between 0 and 1 and greater than 1. Okay, so what do I plug into? I plug into this derivative. Okay, I'm going to plug into this derivative right here. Okay, and remember, I only need to know positive or negative. Okay, so I guess you can use a calculator here if you wanted to. What's a good number between 0 and 1? Good number between 0 and 1. You guys okay, like 1/2? Okay, and then what's a good number bigger than 1? 2. Okay, so you plug in here. I just need to know positive or negative. If you go into your calculator and hit ln of 1/2, if you know how ln looks, just FYI, this is what ln x looks like. Right here, this point is 1, 0. Okay, so anytime, this is ln of x, anytime you're between 0 and 1, you're going to be negative. Anytime you're bigger than 1, you're going to be positive. Okay, but you have a calculator, you could plug it in if you want. So ln of 1/2 is going to be negative. So you have negative over 1/2, which is positive. So negative divided by positive, I'm plugging in 1/2, is going to be negative. Okay, if I plug in 2, I'll have 2 ln of 2 over 2. The 2's actually cancel out. So I have ln of 2. I just need to know ln of 2 positive or negative. You could put it in your calculator. But over here, if you know what ln looks like, ln of 2 is always positive. Okay, so this one's going to be positive. So I have negative, 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 positive, positive, positive. If y prime is negative, then y is decreasing. If y prime is positive, then y is increasing. Okay, I don't even know the question. The question is, okay, is there a relative max or a relative min? Guys, look at the picture of y. Is there a relative max or a relative min? Relative min, okay, and where is a relative min at? X equals 1. So just by process of elimination, which one's your answer? C, okay, for the ones we have in class. It's 1, 0 is a relative min. Those of you guys who are on my math lab. 1, 0 is a relative min. Okay, what other questions do you guys have? These are great questions. Did anybody try number 3? Do you guys want to do 3 together? Okay, let's do number 3 together. Okay, I'm taking the derivative of ln of 5x. Okay, the key here is making sure I know what my u is. Do you agree that this is your u, right? It's the argument with the ln. Okay, so my answer is u prime over u. Everybody good with that? If I can get u prime over u, this is the answer to this problem. Okay, if this is my u, what's u prime? What's the derivative of ln of 5x? Very good. 5, well, it's 5 over what? 5 over 5x. You see that? Because this is, the answer to this is u prime over u. This is my u, right? Well, if this is my u, what's the derivative of ln of 5x? Isn't the derivative of ln of 5x 5 over 5x, right? So that's the 5 over 5x. What's my u in this problem? ln of 5x, okay? So that is my answer. You can simplify it a little bit. Do you see the 5's cancel? So this is really 1 over x ln of 5x, okay? And guys, what did I tell you about numerators? When you have numerators, what can they do? They can bounce out, okay? They can't go to the denominator, but they can bounce out. So if this bounces out, what you get, and remember there's a 1 here. Remember, everything's always multiplied by 1. So this is 1 over ln of 5x times, bounce the 1 over x out, and 1 over x. So somewhere look for that answer. You could also do dividing fractions easiest pi, flip the second and multiply. You'll get the exact same answer as bouncing out, okay? I like bouncing out, but it really is mathematical, I promise. I make up some stuff, and some stuff I lie to you, and some stuff are downright not true, but this one actually works, okay? Let's do another one. You guys want to just work on your own? You're welcome to do that too. Those of you guys online, is there any problem that you're stuck on or you're having trouble with? We could do one of these. Go ahead. Number 15. All right. Number 15. It has t's in it. I don't really like that. A lot of times I'll change my t's to x's, but it's fine. You've got this t4 minus 2, t3 plus 1, and you want to take the derivative of this, right? Do you see when I take the derivative of this, this is product rule. There's nothing wrong with product rule, okay? But I also know that 1 log multiplication equals what? 2 log summation, okay? And if you don't remember it, all you have to do is stand in front of a calculus class and try to remember that you put your logs together first. So it's 1 log multiplication equals 2 log summation. Let me just call this y. Okay, so let's go ahead, turn this into 2 log summation. And whatever this log is, you just copy it. It just gets copied, okay? But guys, make sure when you come down, the log disappears when you take the derivative. Okay, for some reason, some students, when they take the derivative, the log is still there, okay? It disappears when you take the derivative. So let's go ahead and take the derivative, okay? Do you see, you thought you had to do one, you thought you only got to do one problem, but oh boy, you get to do 2, okay? This one plus this one. What's the derivative of log 2 to the t to the 4th minus 2? 4t cubed over t4 minus 2. Is everybody good with that? And you don't need an ln of anything, because if you remember, this is really log e, right? So if you actually had an ln, it would be ln of e, right? But what's ln of e? What's ln of e? What exponent is really here? 1. If you log a tree, the cat falls out. So this just turns out to be 1. Do you guys see that? So that's why ln, you never have to put this ln of a, but it really is there. Okay, you have that ln of a there. Okay, and then you add the derivative of this side, which is, now be careful, when you take the derivative, the logs disappear. Okay, so this will be 3t squared over t cubed plus 1. Okay, and somewhere, hopefully, that's an answer. Did they actually get a common denominator? They actually did. They actually did, right? Okay. Yeah, on your test, you will have to do some common denominators. So it's worthwhile just getting a common denominator here. Okay, guys, if you wanted to get these to have the same denominator, on this side, you need to multiply by t3. Let me do it in a different color. t3 plus 1, t3 plus 1. On this side, you're going to have to multiply by t4 minus 2, t4 minus 2. Okay, so the common denominator here would be, you're going to distribute this 4t cubed, which is 4t6 plus 4t cubed. That's your, oh, sorry, what'd you say? Oh, it doesn't? Oh, wait, so we're good? Oh, we're good. Okay, then you're done. You're done. Okay, you guys can pick the right answer then. Thanks, Haley. All right, what other questions do you guys have? You might have to on your test though, so just make sure you know how to distribute.
Miss Chang,
Yeah, go ahead, Mel.
could you do number 9?
Number 9.
Yeah, it's like x to the 7th log 4x.
X to the 7 log 4x. Okay, tell me yours because mine's a little bit different from yours.
F of x equals x to the 7th log base 4 to the x.
Like that?
Yeah, like
okay.
that.
So this is going to be product rule. So it's going to be the derivative of the first times the second plus the derivative of the second. What's the derivative of log 4x? It's u prime over u. So do you see it's 1 over x, but don't forget what? ln of 4, okay? The derivative of the first times the second plus the derivative of the second, don't forget, times the first. Okay, so if I simplify this, I'll get 7x6 log 4x plus x7 over x log 4. Okay, and if you look at the multiple choice, very likely they canceled out 1x here and 1x here. Okay, so you probably only have an x6 here, and this x got canceled out, x1. Okay, did that match with any of your choices, Mel?
Yeah, I did. Thank you.
Okay, good. Okay, your numbers in class are different, right? Because Mel's numbers are different. Problem like this. I don't know which problem that was.
Oh, yeah.
Okay, can we do it together? Can someone tell me what problem this is? I don't remember. Number 16. Okay, so guys, look on your homework on number 16. It's been a long time since we've done the definition of a derivative. Okay, you had a problem that looked like this. Now go look at your formula sheet. On the front of your formula sheet, you have a formula that looks like this, okay? It's the alternate form of the definition of a derivative. And if you haven't memorized, it's more likely that you would look at this and say, oh, this is a definition of a derivative, okay? This is actually equal to, let me just think about the definition of a derivative. The definition of a derivative is equal to, one of the formulas is x goes to c of f of x minus f of c over x minus c. Okay, let's see if this really fits this. Okay, if this is e minus 2, if it's c, then this is also e minus 2. Are those places the same numbers? Yes, okay. If this is x minus, this is x minus, that looks good. If this f of x is ln of x, okay, so this is ln of x right here. This says if I plug in my c into my f, I'll get 2. Do you guys see that? Or actually negative 2, you'll see why. If you plug in your f of c, so f of c should equal 2 or negative 2, right? Because this is a positive here. Okay, so let's take in my f. My f is ln of x. So my f of c is equal to ln of x. Plug in your c everywhere there's an x. Okay, but what is c in this problem? E to the negative 2. Okay, if I plug in e to the negative 2 into f of x, do I get negative 2? Yes. Okay, so do you see that's where they got this positive 2? Okay, because this was actually negative 2. All right, if all those things are true, then this limit is equal to the first derivative, right? So all you have to do is get the first derivative. Remember, you've done this before. Get your f of x, find your f of x, take the derivative of it, and then turn it into a number, okay? So take your f of x. What's my f of x? ln of x. What's the derivative of ln of x? Which is beautiful, okay? And then you need to plug in your c, okay? Because this is f prime at c. What's my c in this problem? Okay, so e to the negative 2 is equal to 1 over, everywhere there's an x, I'm going to put in e to the negative 2. Do you guys see why I'm choosing e to the negative 2? It's really just this number here. It's your c, okay? So that's e to the negative 2. So my answer should be, change this to a positive exponent, right? Move it to the top. And I think that's it. Okay, does anybody have the answer? It's right. Okay, so that's the answer. All right. What other questions can I help you guys with on the homework? Guys, if you're online, I can help you with your problem too. I mean, only your calculus problems. Okay, let's look at number 11, guys. So we're taking the derivative of ln of 12x. So the derivative of ln of 12x. Okay, you agree that whatever it is, it's u prime over u, right? That's the formula. Okay, now let's just agree on what the u is. The u is the argument for your ln. So here's your ln. So this is your u, which is kind of weird, but it's kind of embedded, right? It's kind of like I don't know, it's kind of like those Russian dolls, right? There's a doll inside a doll inside a doll, okay? All right, so if this is u prime goes on top. What's u prime? If this is u, what's u prime? Do you see where he got that? Right? Because if I say if I say ln of 12x and I say, what's the derivative of that? Wouldn't you say that the derivative of that is 12 over 12x? So if this is your u prime is going to be 12 over 12x. Now, what did I say was my u? And so that would go in the bottom. Okay, so come on in. All right, guys. Okay, so guys, if I have 12 over 12, what's 12 over 12? 1. Okay, so do you guys see that this is actually 1 over x? Is everybody good with that? There's actually x in the denominator. So this is your answer, guys. 1 over x divided by ln of 12 over x. Is there a multiple choice here? Okay, if you had this on your test, though, it would be simplified. Remember what I tell you about numerators? What can numerators do? They can bounce out. Okay, so this would be 1 over x times 1 over ln of 12x. Okay, we're doing find the relative min and relative max. Y equals ln of x squared. Okay, guys, if they say increasing, decreasing, relative max, relative min, what's going to be our strategy? What derivative do we need? The first derivative. You just need the number line on the first derivative test, okay? So if you need the derivative, let's go ahead and take the derivative. So this is going to be 2, it's chain rule, 2 times 1, ln of x, take the power down by 1, and take the derivative of ln of x, which is 1 over x. Do you guys see that? Okay, so right here, oops. Right here, I'm trying to see if I can simplify it any. I get 2 over x times ln of x. So let me just say 2 ln of x over x. Okay, so that's the derivative. And what do you do with the derivative? How do you get this y prime number line? You set y prime equal to 0 or d/e. Okay, so this would be 2 ln of x equals 0, or 2 ln of x over x equal to d/e. D/e is really 1 over 0, and this would be 0 over 1. Okay, if I cross multiply here, I'll get 2 ln of x is equal to 0. Okay, be careful with this. So I'm going to try to solve for x. That's my critical point. All right, divide both sides by 2. You guys good with that? Caroline, are you with us on this? Okay, divide both sides by 2. Okay, how do I get this x out of the ln? Yeah, it's not really multiplying by e, but you're eing both sides. Does that make sense? It's called exponentiating. So you're exponentiating both sides. So really what you're getting is e to the ln of x equals to e to the 0, right? Okay, so right here, guys, okay, if you tree a log, what happens to the cat? Yeah, it turns out it's the same as if you log a tree. Okay, so this is x. Okay, guys, what is e to the 0? 1. So x is 1. So that's one of the numbers on my number line. Okay, that's one of the critical points. Okay, over here, let's get other critical points. Guys, what can x not be? I mean, this is equal to d/e, right? So what is x not allowed to be here? It can't be 0. So I'm going to put a 0 here. That's another one of my critical points. And actually, another thing is that this x, do you see this x? It can never be less than 0. Okay, you can try it. Put in ln of -5, or ln of -3. It'll explode. Okay, if you look at your ln graph, okay, your ln graph looks like this. Okay, ln is never less than, like, there's nothing ever here. Okay, so what I'm going to do is for this problem, ln is, thanks, Mom. You can put it there. This problem, you're never going to be to left of the 0. So I'm just going to cross that out just to save myself some time and also know that this x can never be less than 0. Okay? So go ahead and put numbers in here. What's a good number between 0 and 1? 1/2, is that okay? What's a good number bigger than 1? 2. Okay, so guys, all I need to know is positive or negative. So I'm looking at this right here. You agree with this? I'm looking at this. Okay, so all I need to know is positive or negative. Okay, so if I plug in 1/2, then this is 2 ln of 1/2 over 1/2. That's good with that. And all I need to know is positive or negative. Okay, so ln of 1/2, is that positive or negative? Guys, look at the picture. This is 1, 0. If I have ln of 1/2, is ln positive or negative? Negative. So this is going to be negative on top and positive on bottom because 1/2 is positive. So negative divided by positive is negative. Okay, so let's do ln of 2. Okay, so if we did ln of 2, it'd be 2 times ln of 2 over 2, right? 2 times ln of 2 over 2. Okay, now I just need to know positive or negative. You guys get the 2's actually really cancel out here. Okay, so what's ln of 2? Is that positive or negative? Positive. So this will be positive, positive, positive. That means if y prime is negative, y is decreasing. If y prime is positive, y is increasing. Guys, is there a relative max or relative min here? Relative min. Where is it at? 1. Okay, so go find the multiple choice where you have a relative min at x. This is x equals 1. Okay, and that's how you do this problem.